What's up, Algebra 2? Stir up here. Hey, so we're going to be analyzing some graphs of some quadratic functions and do some vocabulary. So the first thing, the domain is oops, sorry. The domain are the set of x values. Okay, we also call that input. The range are the set of y values, which is sometimes called the output. The y-intercept happens when the x value equals 0 and it crosses the vertical axis. The x-intercept is where the y value is equal to 0 and it crosses the horizontal axis. And interval notation would be when we're talking about, we're writing it as a set of parentheses. We might have a hard bracket and a soft bracket. We could have two hard brackets, and it's just a matter of how we would do it. A hard bracket would mean we include the point. A soft bracket means that we don't get to the point or we don't go to the infinities. All right, so if we identify the domain, so this graph is going to go forever to the right and to the left. So my domain in interval notation is going to go from negative to positive infinity. My range is going to go from hard bracket -4 to infinity. Do we have a minimum or maximum value here? And this happens because parabola opens up. We have a minimum value. So my minimum value of this is going to be equal to -4. It's the y component of the vertex. My roots are where it crosses the x-axis. So it's going to cross at 2, 0 and at -2, 0. And my vertex in this case is going to be 0, -4. And then the axis of symmetry is x equals 0. Remember, that's the line that we could fold the parabola over, the vertical line we could fold it over. So the intervals where it is increasing, okay? Increasing means that I would be able to take 2 points along this part of the red line and I could find the slope. So from 0, soft bracket though, to infinity, it's increasing. Okay, right at 0, it's actually a horizontal line, and then where is it decreasing? It's decreasing over here. So if I were to pick any 2 points in that blue portion, that would be, if I were to find the slope, it would be a decreasing slope or a negative slope. So that would be from negative infinity to 0. And again, it's a soft bracket at the zeros because right at 0, it's a horizontal line with a slope of 0, and the infinities always have a soft bracket because I can't get there. All right, so this one again, the domain is going to be negative to positive infinity. Okay, so because it goes forever right and left. The range is going to come from negative infinity. It's coming from the bottom, and it's going all the way up to 1. And that's a hard bracket at 1 because the graph exists vertically in that direction. The roots for this one are going to be -4, 0 and -2, 0. And my vertex appears to be -3, 1. The equation of the axis of symmetry is always the x component of the vertex, so x equals -3. And the intervals where this is increasing, so this is where it's increasing on our graph. Okay, so it's increasing from negative infinity, getting up to -3, and it's a soft bracket because right at -3, it is a slope of 0. Where it's decreasing, on this case, is down over here. So if I were to pick any 2 points over there, my slope would be negative. So from -3 to infinity. And that's all we have for that problem. Okay, so we're going to keep going. The domain is negative to positive infinity. And maybe you're starting to see a trend with parabolas. The domain's always negative to positive infinity as long as they open up or down. The range in the y direction is going to start at 0 and go to infinity. Hard bracket at the 0 because it does include at that point. The roots on this one, we actually just have a root, and our root happens to be negative 3, 0. Because it just kisses the x-axis, our vertex is also the same as our root. Our equation for axis of symmetry is the x component of the vertex, so x equals negative 3. And where is this increasing? It's increasing here. So if I pick any 2 points along there, I'd have a positive slope. So from negative 3, soft bracket, to infinity, and the soft bracket, because the slope exactly at negative 3 would be 0. And where is this decreasing? It's decreasing over here. So from negative infinity to negative 3, again, soft bracket. All right, so the graph models the height of a platform as a diver as a function of the distance of the diver from the edge of a platform. Okay, so what is the y-intercept? So the y-intercept appears to be 0, 10. And what does that mean in the context of the problem? That was the height of the platform that the person jumped off of. That was the height of the platform, or the starting point. Okay. What is the greatest height the diver reaches? Well, the diver appears to reach 12 meters because that's part of at the vertex. So the person obviously jumped up, or the board sprung this person in an upward direction. And what does the x-intercept mean in the context of the problem? Well, this part of the graph right here doesn't mean anything to us. It's from here all the way to here means something. So this x-intercept is at 3.5. So at 3.5 seconds, while the person is flying through the air, they're going to get to 0 feet, or meters in this case, I guess it is, means they entered the pool. So what does the x-intercept mean in the context of this problem? Well, this one means nothing. This one over here means when the person actually entered or hit the ground or hit the water, whatever they're going into. I hope it's water. All right, so quick review. This one would have a vertex at 5, negative 4. So 5, negative 4 is down here. And if I pattern graph, it's not going to pattern graph as 1, 3, 5. It's 2, 6, 10. So I'm going to go right one up 2, left one up 2, right one up 3, left one up 3, so on and so forth. The second one we'll do in blue, so I'm going to use the negative b over 2a. So I get negative 8 over 2 times 1. So it's going to give me negative 8 over 2, which is negative 4. I'm going to plug negative 4 back in here, so I'm going to get 16 minus 32 plus 8. So that's going to be 24 minus 32, which is negative 8. So negative 4, negative 8. My pattern graph is going to be 1, 3, 5, so I'm going to go right one, up 1, left one, up 1, right one, up 3, left one, up 3. And here is our parabola. And then our last one. This is going to give me my roots, so it's going to cross at 6, 0 and at negative 2, 0. So 6, 0 is here, negative 2, 0 is here. The number that is halfway in between those, let's say you go 4, 0, looks like 2. So the vertex is going to happen at 2, something. So we're going to plug 2 back in. So 2 minus 6 is negative 4. 2 plus 2 is 4. Negative 4 times 4 is negative 16. Half of negative 16 is negative 8. So 2, negative 8 is going to be down here. This pattern graph actually goes right one up half, left one up half, right one up 3 halves. So there's half, and there's the other part. Left one up that much. And it would keep going that way. So this is a nice fat parabola. Okay, so if we want to change this to standard form, so remember standard form looks like this, ax squared plus bx plus c. So what I'm going to do is I'm going to FOIL this out. So I'm going to get x minus 5 times x minus 5, and then minus 49. So I get x squared minus 10x plus 25 minus 49. combine my like terms. So my standard form is going to be x squared, so y equals x squared minus 10x minus 24. And then the factored form, let's see if we can factor that. So that's going to give me, I'm going to have x and x. And then what two numbers multiply together to give me negative 24 and add together to give me negative 10. And I think it's going to give me negative 12 and positive 2. So there's our intercept form. So that would tell us where it crosses the x-axis. All right, so it's in standard form. So we want to put it in vertex form. So to go to vertex form, so go this way, we have to complete the square. Okay, so remember with that, I'm going to divide everything by 2. Okay, so I get y over 2 equals x squared plus 6x minus 16. I'm going to make a space. I'm not going to move that 16 over. I'm just going to make a space. And then I'm going to go y over 2 equals x. This sign's a plus, so I'm going to have a plus here. Half of 6 is 3. 3 squared is 9, so if I add 9, I also have to subtract 9. And then I want to get rid of this 2. So I'm going to multiply both sides by 2, or everything by 2. So those cancel. So my vertex form is y equals 2. You don't need to put that over the parentheses. Minus 50. Our factored form, we might be able to do this. Let's see. I have a 2 I can pull out front. So I get x squared plus 6x minus 16. So then I get y equals 2, and we're going to go ahead and factor it. X and x, I'm going to have a positive, I'm going to have a negative. So I'm going to have a positive 8 and a negative 2. And there's my factored form. Don't forget to have that 2 out in front. And then if it's in standard form, or in factor intercept form, we'll put it back in standard form. So I need to make sure I FOIL. X squared plus 4x be plus 14x plus 40. Distribute the negative. There's our standard form. If I want to put this in vertex form, I need to complete the square. So I'm going to multiply everything by the negative. All right, so we want to complete the square. So we're multiplying everything by the negative. So everything here is going to change to positive. Okay, we're going to hold on to that negative over there. We'll deal with it at the end. I'm going to make a space between the linear term and the constant. I'm going to go ahead. Notice to keep that negative y keep coming down. Being that's a plus, it's going to be a plus here. Half of 14 is 7. 7 squared is 49, so I'm going to add 49 and subtract 49. So this is my completed square. If I were to FOIL out x plus 7 and x plus 7, I'd get x squared plus 14x plus 49, and then that becomes a minus 9. But you remember that negative here? Yeah, I'm going to multiply it. So the negative is going to be out in front of the parentheses here. It doesn't get distributed in, but it does change this sign here. Changes it to a positive. So that is my vertex form. Okay, good luck to you. If you have any questions, you know where we can answer them. Have a great day, everyone. Take care of one another. Bye-bye.